I'm introducing FlowScale. This is a tool that we've developed at Indiana University for traffic load balancing using OpenFlow. And one of the features is that it replicates, we're trying not to reinvent the wheel. We're replicating some of the commercial and open source interfaces for hardware load balancers, but instead of having a hardware appliance to do load balancing, we are using existing hardware. Instead of using existing hardware, we're using a simple layer 2 switch that supports OpenFlow to actually do the load balancing. This is a little different from some of the other demos in this session, that this isn't really an experiment in sort of the gradient between an application and an experiment. This is very far off to the application side. But one of the things that we're trying to do is to provide incentives for GENI deployment, that we're building out applications that would be very useful for network operators, network administrators to deploy out for their own networks. And it becomes very easy for the network operators to opt in their networks, since it's using the same technologies that GENI will need to have deployed. And as Chip said at the beginning of the session, there isn't enough money to buy a separate internet for researchers. So this application such as FlowScale help deploy out infrastructure that can be used for research. And it's really built for production use. Our demo will show what we've done with the campus intrusion detection system and how we load balance traffic from the entire campus through our IDS and balance it with FlowScale. And one of the ideas is this is sort of the benevolent spyware diffusion strategy, that there's a checkbox in these applications that, okay, I've deployed out this infrastructure. I just hit a checkbox and it becomes GENI enabled, and experimenters can use the infrastructure. So some of the concepts behind FlowScale, the idea is that it's a load balancer as a service. You don't need the hardware. You can have a website that is in your organization or outside of your organization. You point your switch to the the controller. The controller does traffic load balancing. We've also been working on distributed deployments, where you have multiple load balancers and having intelligence to distribute load over remote sites. So in case there is a spike in traffic, it will be able to use long distance links and dynamically push traffic to a secondary site, for example. And we've been working on integration with OpenFlow, other OpenFlow tools such as layer 2 provisioning and VM migration, and incorporating that into the load balancer. So you have a set of applications that can work together to provide integrated service. And also we're trying to make a very simple deployment we're trying not to have very much complexity in the application itself. It should be very easy for operators to use. It's a very simple strategy for load balancing. We hash through OpenFlow fields such as IP source and destination, and split up traffic, rotating through the available ports. We have application layer tests, similar to the way a commercial load balancer would work, that where it tests, it has a set of tests that can test link or application tests on the remote, the service that it's connecting. There's ability for failover redundancy. When there is a link outage, it will move the traffic to other ports, and it has a simple web UI for administration. So our initial deployment, which we just started passing traffic last week, is the Bloomington and Indianapolis campuses of Indiana University. This is our IDS cluster. We have 12 sensor ports per campus, 10 gigabit links on 10 gigabit ports on all links. It actually gives us, with two switches, almost 500 gigabits of total capacity. All of the ports can forward at line rate, and we currently have the Bloomington campus is actually sending traffic. So let's go to the demo. So essentially you have a bunch of input ports. This is just adding traffic. The colors are just indicating its status according to OpenFlow, to FlowScale. There's a single load balancer in this situation. The configuration could handle multiple load balancers. All you need to do is point the switch to the controller, and there's a bunch of sensors here that show all of the traffic, all of the output ports for the load balancer. And this is showing our live traffic on the Bloomington campus. We currently send in almost 2 gigabits of campus from the core through FlowScale. We balance it out, so oops. Let me see, I didn't get a network connection. Yeah, it doesn't have the network connection. You have a port. Hold on. So essentially it shows the okay, that's better. So it shows total traffic. You can click on a link and it shows how much traffic is on each individual port. There's an administration interface where you just select the input ports for a certain set of traffic, the output ports, and a set of rules to define what traffic gets load balanced. You select that traffic, enter the rule, and it will automatically choose the mechanism to hash that data and create a load balanced traffic distribution. So one of the things we're looking at future directions for this is we're looking at incorporating OpenFlow improvements. We're having a code release of this code, so anyone who's interested in it can use it. We're having a distributed demo. We're just showing the Bloomington campus. At SC, we will demonstrate how it can be used for cloud bursting type applications where you need to quickly set up a additional load balancer and route traffic to a other site. And we're looking at research ideas where we can have plugin modules and integration with other tools to allow researchers to build modules that incorporate the load balancing technology and be able to distribute and be able to implement different distribution mechanisms. Okay.
Thanks, Chris.